Hello, welcome to my channel. In this video, we are going to be studying the behavior of a rolling object up an inclined plane. So let's consider a figure. So from this figure, we notice that once this object moves in this direction, as it gets to this point, it goes up the inclined plane. But we notice that at a point, this object will stop. So the question is, what is the distance traveled before it comes to stop? So to solve this problem, first of all, let's label this axis properly so that the understanding will be clearer. So we can label this one as our X, we can label this one as our Y, then we can label this one as our Z. Now to solve this problem, we are going to be using our energy conservation theorem, or conservation of energy theorem, which is giving us potential energy at point 1 plus kinetic energy at point 1 will be equal to potential energy at point 2 plus kinetic energy at point 2. So from this figure, we can consider this part as our point 1, while this part where it stops as point 2. So you realize that the potential energy at point 1 for this object is 0, while the kinetic energy will not be 0. Potential energy at this point is not 0, while the kinetic energy at this point where it gets to stop is 0. So if that's the case, so this one will go to 0 and this one will go to 0. So what we are left with is the kinetic energy equal to the potential energy at point 2. Kinetic energy at point 1 equal to potential energy at point 2. But it is important for us to know that the kinetic energy of a rolling sphere is giving us half of mv squared plus half of the moment of inertia plus angular velocity. So this part is the kinetic energy 1 equal to the mgy. These are y is this vertical height traveled, the height mgy, right? As long as this sphere does not slip, then this is the kinetic energy of a rolling sphere. If it slips, then this one will go to 0. If it rotates without slipping, without moving in this direction, then this one will stay and this one will go to 0. So now that we have established this formula, then let's simplify. Let's factorize our half. We have this. Then we take this 2 to this side. We have this. At this point, we want to look for what we are interested in is this z, but we can find our y in terms of z. So, but from here, let's make our y the Soviet formula. And if we replace our I, the moment of inertia of a solid sphere is half of mr squared, while this angular velocity is v squared all over r squared. This one can take care of each other. We can factorize our m out and make our v squared the Soviet formula, or make our y the Soviet formula. So we have this plus this equal to this. The 2 is already out here. So at this point, we can take care of our m. And if we simplify this, it gives us 3 over 2 mv squared equal to 2 mgy. We can cancel our m and make y the Soviet formula, and we'll get this expression. At this point, since what we are interested in is our z, not our y, we can make our y in terms of z. So, and that gives us sine 30 opposite all over hypotenuse, sine 30 equal to y all over z. So we can make z the Soviet formula and replace it with y, and that gives us z sine 30 equal to y. So wherever we see our y, we'll replace with what? Sine 30. And at the end of the day, we have 3v squared all over 4g equal to z sine 30. And we know our sine 30 is half. We have this. And at this point, we'll make our z the Soviet formula. We have this expression. So now that we have this, we can substitute the value of V as 2 meters, G as 9.8, and we'll get our answer here. Right, I think this particular V is supposed to be 2. There is a typographical error here. Here is supposed to be 2. By the time you simplify, you get 0.61 meters. I hope this helps. Please like, share, and subscribe to my channel. Thank you.